So one way to simplify trig identities is to factor. So we're going to start by looking at some problems where we're going to factor an algebraic expression and then see what that looks like if we factor a similar trig expression. So this is simplifying trig expressions. Simplifying with factoring. So let's say I have the expression x squared y squared minus x squared, and I can factor this. I can factor out an x squared, and then what I'm left with is y squared minus 1. And I'm just going to leave it like that. In the case of the trig expression, I can factor out a sine squared x, and then what I'm left with is cosecant squared x minus 1. And the way that we would use this to simplify, two different ways. If this was an equation and I had it set equal to 0, then I now have two factors that I can set equal to 0. Or I can use my identities to simplify this further. So for example, cosecant squared x minus 1 is actually cotangent squared x. And so I have sine squared x times cotangent squared x. That's going to be sine squared x times cosine squared x over sine squared x. And that's going to equal cosine squared x. Okay, notice there's more than one way to do this. Sine squared times cosecant squared is equal to 1. So 1 minus sine squared is equal to cosine squared x. That's another way to look at the problem. Here I have 1 minus 2x squared plus x to the 4th. So that's going to be 1 minus x squared squared. And if I take my trigonometric expression, I can write that as 1 minus cosine squared x squared. And 1 minus cosine squared x is sine squared x. So we have sine squared x squared will equal sine to the 4th x. And here we have 4 terms to factor by grouping. I can factor out x squared, and I'll have x minus 1. I can factor out a negative 1, and I have x minus 1. And so this gives me the expression x minus 1 times x squared minus 1. Notice for an expression like x squared minus 1, I know that can factor to x plus 1, x minus 1, but we want to keep our squares with trig expressions so that we can use our Pythagorean identities. So I can factor out secant squared x, and I have secant x minus 1, and then minus 1, secant x minus 1. So then I have the expression secant x minus 1 times secant squared x minus 1. Secant squared x minus 1 is equal to tan squared x. So now we have an expression. We've taken a sum or a difference and we turned it into a product. So it may not look simpler, but if we were solving an equation, we now have it in a form that we could use to solve the equation. And that's simplifying by factoring.